Hey guys, welcome to day 2 of polar. Yesterday it was polar coordinates, and today we're going to talk about polar equations. Okay, so we're used to equations with x's and y's, and since x's and y's can also be written as r's and thetas, you can also have what are called polar equations as well. And today you're going to see some polar equations, and we're going to graph them. Now we're going to start off with some really basic polar equations, like r equals 5. Well, that literally means the radius is always 5. So if you have this graph, you can just go out 1, 2, 3, 4, 5, and that would be a point that would be on this graph, but it's not the only point, okay? r equals 5 means whatever your angle is, r is 5. So it's not this point, it's every point that's on this circle. Okay, it's this angle 5 and this angle 5 and all the points in between them. So all you do is go out to that fifth circle and then trace it to the best of your ability. I have to turn my paper. It's the only way my hand works. Okay, so that is the graph of the polar equation r equals 5. Real easy. The next one says theta equals negative pi over 4. So let's find that angle. So this is pi over 4, right? That's pi over 4. So negative pi over 4 would be right here. Negative pi over 4. Now, theta always equals negative pi over 4. The r can be anything. Okay, so what it is, it's going to be a straight line that goes towards the angle, but also goes away from the angle. Why? Because those would be all the negative r's. Okay, so r can be anything. R could be 1, 2, 2.2, 2.3, whatever, but it could also be negative. So all of these going that way as well. So that is the graph of the polar equation theta equals negative pi over 4. Okay? The third example, r sine of negative 3. Now, here in a second, I'm gonna show you some equations where we're actually gonna type things into our calculator. This one, it does look like there's some operations going on, but we don't need to put this in our calculator. R sine. From yesterday, we talked about, we were converting between x's and y's and r's and thetas and everything, and we found that y is equal to r sine theta. So this is something we're actually familiar with. This is just like y equals negative 3. Now, it's a little harder to graph on this. Y equals negative 3 would be go down 3, and then draw a horizontal line. But we don't have a horizontal line. We've got these circles. Okay, so to the best of your ability, draw a horizontal line, and you're going to try to look at this polar axis and see if you can just kind of make it parallel. Ooh, I'm already going off. Something like that. That's not too bad. Okay, so that would be r sine equals negative 3 because r sine is y. If I would have given you r cosine, then that would have been x. Okay, and so you just translate it into x, think it's a vertical line, and then you just go out to where you need to go out. All right, but here's where they're going to get a little more interesting. Okay, we're going to graph this equation. R equals 1 plus cosine theta. And again, this is where I think of these backwards. Theta is going to be our input. R is going to be our output. Okay, so even though they write the points r theta, that's not how I look at it. Okay, I look at it as theta. We're going to plug this into the equation, and we're going to get these r values. So what you're going to do is you're going to grab your calculator. Notice that all of these are in degrees, so we need to make sure our calculator's in degrees. Mine is. It's got the little DEG right there. And then just one at a time, we're going to put these values into this equation. So what is r if theta equals 0? So we're going to do 1 plus cosine of 0, and we're going to get 2. Okay? And then we're going to do our next one. We're going to do 1 plus cosine of 30. So what's that? I'm going to write 1.86. Technically, I'm just going to write 1.9. Okay, when we graph these, okay, going out a tenth is going to be hard enough. There's no way you can go out to like the hundredth place and you can tell the difference between 1.86 and 1.85 or whatever. Okay, so going to the tenth will probably be good enough for our graphing. All right, 45. 1 plus cosine of 45. 1.7. Okay, so we're just going right down the line. 1.5. Just stay with me. Keep going. I'm going to show you a little trick here in a second. Cosine of 120. What do we have? 0.5. Okay. 1 plus cosine of 135. We'll call that 0.3. So 0.3. 1 plus cosine of 150. Ooh, 0.1. I'm just going to call that 0.1. Sorry, there's a glare. There you go. You can see mine a little bit better. 180. 1 plus cosine of 180 is 0. Oh, cosine of 180 is negative 1. And then negative 1 and 1. Okay, 0. All right. How about 210? Let's see what happens when we do this. 1 plus the cosine of 210. And we have that 0.1. I feel like we already saw this. Right here. 0.1. These graphs are symmetrical. And so once you get a repeat, that repeat is going to continue. Okay? If this is 0, and then 30 degrees from this is 0.1, but also 30 degrees past 180 is also 0.1. I guarantee that 225 is going to be 0.3, 240 is going to be 0.5, and then 1, 1.5, 1.7, 1.9, and then you're always going to end where you started. Okay, 0 and 360 are the same. They're the same angle. So if that has a value of 2, that should have a value of 2. And that's our T-chart. Okay, that's all we're doing. We're doing T-charts that we need to come over here and graph. Okay, so let's take a look at this. All right, so a couple things. First off, my graph goes 1, 2, 3, 4, 5, 6. Okay, so my outer ring is 6. If you look at the numbers I have, the biggest R value I have is 2. So this entire graph is going to take place inside this circle right here. And I've got a lot of decimals that I'm going to have to try to figure out. What's the difference between a 1.9 and a 1.7 and a 1.5? So another thing we can do is we can scale this. Okay, just like you can scale an X and a Y to make things fit better. Okay, I'm going to scale this. Scale by 0.5. So this is not 1. This is going to be 0.5. This is going to be 1. This would be 1.5. This would be 2. And that's as far as I need to go. Technically, I could have scaled it by a third, I guess. And then this could have been 2 out here, but that would have been even trickier. Okay, so this is what we're going to do. That's 0.5, 1, 1.5, and 2. So what I've done is I've taken this graph that we're going to graph. I'm going to blow it up a little bit so we can see it better. Okay? If you do not do that, you're just going to get a picture like on your homework. If you don't do that, your picture is going to be smaller than mine. Doesn't mean it's wrong. It's just it's not going to look exactly like mine when you check your answers. Okay? So let's see what we got here. We've got 0 and we've got 2. So 0, 2 is right here. Then 30. Now that's not the next line. This is 15 degrees. Okay? Here's 30. Okay? 30 and 1.9. So here's 2. I'm going to go around. I'm just going to go around this curve. Here's 30. And then I'm going to go in a little bit. There's 1.9. 45, which is the next line. So what I do is I just jump right over to the next line. There's my angle. And then I back up a little bit. I need 1.7. Well, this was 1.9. This is 1.5. So it's going to be like here. At 60 degrees, I should actually be at 1.5. So the next line would be 60. And that's 1.5. Oops. My pen left a little dot there. That's not a point. And then 90, I'm at 1. So remember, this is a half, this is 1. Now, what I do is, this is like quadrant 1, okay? Let's stop and let's graph what we've got so far. So this graph starts here. It goes up, hits that point, and comes to here. All right, that looks a little different. Okay, and then let's keep going. So now 120. So think about it. This is 120. This will be 135. This will be 150. And this will be 180. Okay, feel free to label your angles here. So at 120, I should be at 0.5. I should be right here on this first circle. 135, I'm at 0.3. So a little bit more than halfway. At 150, I'm at 0.1. So here's 150. Maybe that was a little off. I'm right here. And then at 180, I'm at 0. All right, so again, I've gone, this was quadrant 1. This is quadrant 2. Let's stop and graph this. Okay, and then let's keep going. 210, so here's 210. I'm back at 0.1, so I'm out just a little bit. This is 225. That should be at 0.3, so a little bit further. Then I should be at 0.5, and then I should be at 1, right, at 270. I'm going to stop, draw what I've got. I have to try to purposely slow down. I graph these a little faster. I've done quite a few of them. These are going to be brand new to you. Okay? And then, again, keep going. We've got to connect these. So this was 1. 300, which is here, is 1.5. So there's 1.5. And then I should be at 1.7, 1.9, and then back around to 2. So I need to connect these. And that is our graph. Okay, it looks a little weird, different than anything you've ever graphed before. That has a name. It's called a cardioid. Okay, take a look at it. See if you can see why. Okay, cardioid. If I turn this around, kind of looks like a heart. The top here looks like a heart. Okay, and then it's kind of more rounded off, but still that top part looking like a heart. Looks like when you try to make those valentines in elementary school, and if you didn't make it right, you would maybe not get a heart that looked exactly right, but the top part sure looks like a heart. Okay. That cardioid can go in a lot of different directions. It could have looked like an actual heart where this part was up here at the top. If I would have had a sign, that's what would have happened. Okay. You've got a 1 plus sign, you got a 1 minus sign. Those are going to look more like hearts, whereas the 1 plus cosine had the fat part going to the right in the positive cosine. A minus cosine would have made it go the other direction, okay? But that's called a cardioid, okay? So 1 plus cosine of theta will give you a shape that looks like that, okay? All right, so let's take a look at the next example, and this chart's going to look a little different to you, okay? So I've switched things over to radians. So you know what the circle is going to look like as far as radians. So 0, again, skip this one. This is pi over 6. Pi over 4, pi over 3, pi over 2, and then around and around and around. But if I want to put these things into my calculator, I'm going to have to switch things up on my calculator. So first off, if you have, most of you appear to have something calculator that looks like mine. My calculator has this little DRG button. If you have I think it's a TI-31, like the multi-view, you may have a button that says either mode, and then you can go in and change this, or it may be the math button that'll have you go in and change this. So you may have to experiment for a second. But ours are real easy, and sometimes you'll have like a shift, like you'll have to hit second and be able to access this. But for these, you just hit that button, and then it says degrees, radians, and these are called gradians. We don't want that. We want radians. And now we're all set. So I'm going to do the same thing we did on the first example. I'm going to do 4 plus 2 sine of 0. And it's going to give me an answer of 4. And my calculator knows that that's 0 radians and not 0 degrees. Not that it would change things for 0. But for the next one, I need to type that in. I need to type pi over 6. So I'm going to go back. A lot of you may, if you've got like little back arrows, you can just go right up and then edit that. So I'm going to type in pi over 6. Now I have an easily accessible pi button divided by 6. 5. That's the answer. So my calculator is in radians. It's in radian mode. It's dealing with this pi and the 6. So that's 5. And then I need pi over 4. Okay, we'll change the 6 to a 4. 5.4. We'll change the 4 to a 3. 5.7. Change it to, so these are pretty quick right now. So I got a 6. All right, my next one is 2 pi over 3. Okay, so I'm going to have to go and start over. 2 pi over 3. So 5.7. Now, there's my symmetry. So I can guarantee my next one's going to be 5.4. My next one's going to be 5. My next one's going to be 4. Okay, that'll save me some time. Now, my next one is 7.6. Okay, so let's go back. We'll change the 2 to a 7. Change the 3 to a 6. 3. Now I need 5 over 4. We'll call that 2.6. Sorry, that was a bad 2. My calculator was in the way. 4 over 3. 2.3. 3 over 2. 3 over 2 is 2. 5 over 3 is 2.3. All right, so there's my symmetry again. So it'll be 2.6, it'll be 3, and then it's always going to end where we started. So it's going to end with 4. All right, now on this one, if I look at my output values here, the biggest number I have is 6. Well, that's how many concentric circles I have. So we're just going to scale this normal. We're going to scale by 1. And we're going to go out and we're going to plot 0, 4. So 1, 2, 3, 4. Pi over 6, 5. So I'm going to go up. So here's what I do. I'm already at 4. I'm going to follow the circle until I get to my next angle. And I'm just going to pop out to 5. My next line, I should be at 5.4. So I'm going to pop up. Go to about 5.5, just a little under. My next one should be about 5.7, so I'm getting closer to the edge. And when I get to pi over 2, I should be at 6. So I'm going to stop. I'm going to connect my dots as I go. All right, 2 pi over 3, so that's here. 2 pi over 3. And I should be at 5.7. So now I'm starting to come back down. So 5.7. This would be 5.4. Then I'm at 5. And then at pi, I should be 1, 2, 3, 4. I'm right here. Okay. 7, 6. So, right, this is 5, 6, this is 7, 6. So I should be at 3. So 1, 2, 3. 5 pi over 4, I should be at 2.5-ish. At 4/3, I should be 2 and just under a half. And then at 3/2, so here's 3 pi over 2, I should be at 2. 1, 2. So this graph comes in, and then it kind of flattens out. These are slowly coming in, and they're kind of staying kind of level. And then at 5/3, I should be out at 2.3 again, and then 2.6 again, and then 3, and then I end up where I started. You get that? It's not quite a circle. It's kind of a flattened circle. It may kind of look like a shell to you. This is called a limicon or a limicon. I think there's actually like one of those little, can't think of the accent. There's like a little accent on the C. I think it makes it a soft C. Anyway, limicon. I think it's French. It means snail, not escargot. It means snail, and I think it has to do from that shell shape. Okay, so if you put a little snail head and a little snail tail, you'll see that it looks like a snail. All right, so that's that one. Okay, now next one, 1 + 3 sine. Why don't you try this one? Okay, plug in these values, pause the video, and then when you get done, go back and you can double check my answers and see if you got them right. All right, so here's my chart. I started with 1, and then the numbers started getting bigger, 2.5, 3.1, 3.6, 4. 4 is the biggest value, but it's big enough that we're just going to have to scale this normal when we come over here and graph this. I can't like double it. It'll go off the chart. Numbers start going down, and then they turn negative. Okay, that didn't happen on the last one. Okay, so let's take a look at this and see what's happening. Why are we getting negative values? Well, when you take the sine of an angle in quadrant 3, you're going to get a negative value. Okay, but that should have happened on the last one. Why didn't it happen on the last one? Well, on this one, it did. Okay, when you took the sine of 7 pi over 6, you got a negative. But then that negative was getting multiplied by a 2. Now remember, this number is always going to be like a decimal. It's going to be like negative 0.9, negative 0.8, up to negative 0.1. I mean, negative 1. That's the very biggest that number could ever be. So when you take 2 times that, you're going to get kind of a small negative, and then you're adding 4 to it. I promise this number is always going to be smaller than this. So if you've got a bigger positive number, smaller negative number, you're always going to get a positive answer. But on this one, that negative value that we get right here, 7 pi over 6, we're in quadrant 3, that negative value is getting multiplied by a 3. So that negative is now getting tripled. It's bigger than 1. And then when we add it to that 1, our answers are going to be negative. Okay, so it's the size of these two numbers right here that are causing either these negatives to happen or there's no negatives happening, like in the last one. Okay, this one is also called a limicon. It's called a limicon with an inner loop. So that's going to give you a little hint as to what's going to happen on this shape. So let's start graphing this and we'll see what happens. So again, we're going to scale normal. So 0, 1. And then pi over 6, 2.5. So 1, 2.5. Then I should be at 3.1. I'm just going around the circle. 3.6. And then I should be up at 4. So we started here. All right. 3.6. So now we're back down about 3.5. 3.1. 2.5. And 1. All right, so those are our positives. So now let's look what's going to happen. So our next value is 7 pi over 6, 5 pi over 4, etc. Right? It's 3 pi over 2. Now, we're going away from these angles. So find your angle. This is where if you've got a straight edge, this may help you. Because here's my line, and it continues over here. So this is actually where I'm headed. I'm heading away from this angle. I'm heading towards this direction. Okay, so this is like, think in degrees for a second. This is 30 away from the x-axis, so I'm going to be heading towards this 30 on the away from the x-axis. So I'm headed towards this line about a half. And then 5/4 is right here, so I'm going to be heading towards pi over 4. Okay, it's buddy in the other direction. And I should be at negative 1.1. So 1.1. And then at 4/3, which is here, I'm going to be heading away from 4/3, which is negative 1.6, 1.6, and then I should be at negative 2. So here's 3 pi over 2. Going away from it, this would be the same as going towards pi over 2. So this would be like pi over 2 with a positive 2. Same thing, 1, 2. So here's what happens. They curl up to there, and then they're going to curl back down and complete. So this is 1.6, 1.1, 0.5, and we get that. And that's our little loop-de-loop in the middle. Okay, so it's called a limicon, whatever you want to call it, with an inner loop. So it goes around and has that snail or that shell shape to it, but then it does this little loop-de-loop, a little roller coaster in the middle. Okay? All right, last page. So take a look at the one at the top. A little different. There's no addition going on here. This is simply 2 times the cosine of 2 theta. Okay, so that's what's going to get plugged in. Let me get you started. So 2 times cosine of 2 times, and then whatever your theta is. In this case, it's a 0. Okay, so that gave me a 2. And then again, you can go up and you can change that 0 to a 30. You'll get a 1, and then you can keep going. Okay, so finish out that table. Press pause, finish out the table real quick. All right, so check your table with my table. Make sure your numbers are the same. And then let's go and try to graph this. Now again, the biggest value I have is a 2. So I'm going to scale this. I'm going to kind of blow it up so we can see it a little bit better. So I'm going to scale. Usually the biggest, I just scale by a half. So that's now a half. This is now 1. That'd be 1.5. And this would be 2. So that's where our graph's going to go out to. So 0, 2, that's going to be my starting point. And then here's 30. So 31. So again, that's a half. That's 1. And then at 45, which is here, I should be at 0. So I went from here over to here. Okay? At 60, so here's 60, I'm at negative 1. So I should be going backwards. I should be going, this is 270, this is what, 240? I should be going towards 240. Okay, these angles are 180 from each other. So if that's 60, that's 240. So that's the direction I'm going. And I'm going 1. Remember, we're counting by halves. So that's negative 1. At 90, which is here, I'm going to go away from 90 to negative 2. So 1, 2, that's 1, 1.5, 2. Okay, so I'm going to kind of graph this as I go. So there's 90, negative 2. At 120, here's 120. If I add 180 to it, that's 300. So that's where I'm headed. I'm headed towards 300 right here. And then I'm back to 0. So, okay, so this is doing this. And then it goes back to 0. All right, this is looking unusual. 150, here's 150. I should be at 1. So a half 1. At 180, I should be at 2. So 1, 2, 3, 4. At 210, I'm back to 1. Here's 210. So I'm back to 1. And then I'm back to 0. Okay, so this graph goes up and around and then goes back. Okay. Where are we at? 225, 240. So here's 240, but we're going away from 240. So we're going towards 60. Here's negative 1. At 270, I'm going away from 270. 1, 2, 3, 4. And then I'm at negative 1 again. You probably, once you start to kind of get a pattern going, you can kind of see where this is headed. It's going to head back to 0, so it's going to go up. Come back. And then again, we've got to finish this little branch right here. So it's going to be here and then back. And we get that. That's our shape. Now, if you look down at the bottom, this is called a rose. I know that doesn't actually look like a rose. Maybe a petunia? I don't know. So anyway, it's called a rose. It looks like a flower. Okay, so they call it a rose. These can get kind of unusual. I think there's one on your homework where it's like a 5-petaled rose. So do the best you can on that one. I give you some more points because you really kind of need to have some extra points to really get the shape of it. So when you see a big graph, just plug in the numbers I gave you and see how it works out. Okay? So, but that's a rose. Last one. Okay, this is our equation. R squared equals 4 cosine 2 theta. Well, I don't want to know what R squared is. I want to know what R is. So for this one, R is going to be the square root of all of this, 4 cosine 2 theta. You could leave it like that. You could also pull the 4 out and write this as 2 and just the square root of cosine 2 theta. But that's what we're going to be doing. Okay, so in your calculator, so again, once we do the first one, if you've got a calculator that does this, so 2 square root of the cosine of 2 times, okay, that's what's going on, 2 times theta, so 2 times 0. I'm going to close those parentheses. I'm also going to close my original parentheses, and I get an answer of 2. Okay. And then I'm going to go in, I'm going to change that 0 to a 30. 1.4. I'm going to go in and get a 45. Okay, that's 0. No biggie. And then I'm going to go back and change that 45 to a 60. And I get a domain error. Alright, so what's happening? Remember, as we move around the circle, sometimes cosine values are negative. Well, because that angle's getting multiplied by a 2, it's going to happen pretty soon. When I take 2 times 60, I'm going to get 120. And when I take the cosine of 120, which 120 is technically in quadrant 2, that's a negative value. And I'm trying to take the square root, and that's not going to work. So I'm going to get an error message. Okay, so that point doesn't exist. That's okay. That point's not going to exist. So you're going to get another error message when you do that. That point doesn't exist. Okay, so you got to keep going. You're going to keep getting error messages. And then at 135, it works. You get 0. Now, it looks like we're going to have so what's happening here? We're going to have this big space in our graph. Well, technically we're not. Because where this graph ends, at the pole, this part of the graph picks back up. So you're not going to see a gap. So again, I'm going to scale by a half. So 0, 2, so 1, 2, 3, 4. I'm going to go out to here. At 30, that's 30, I should be at 1.4. So a half, 1, that's 1.5. So just inside 1.5. And then to 0. So it goes up, it comes back down. Kind of looks like the petal of that rose we just did. And then at 135, it's going to start up again. Okay. At 150, so what do we get when we type in 150? So let's go in, 150. Okay, we're back to 1.4, so there's our symmetry. And then it's going to go up to 2, I'll bet. Then let's go and put in 210. All right, 1.4. So we still got that symmetry going. There's 1.4, so I bet the next one's going to be 0. And then I got a feeling the next one, so let's see what happens when we put in 240. Yep, I get an error message. So that's an error message. 270 is an error message. 300 is an error message. Alright, now I'm back to 0, and then it's going to be 1.4, and then it's going to be 2. Alright, so let's see what happens here. So 135, I'm still at 0. At 150, so here's 150, I should be out at 1.4, so remember, half, 1, 1.5, so just inside. At 180, I should be at 2, that's right here. At 210, I should be back in at like 1.4. and then I go back to 0. So let's just go ahead and connect the dots. And then skip, back to 0. So we're back at the pole. So there's no gap. We're just going to start right where we left off. And then at 330, so this is 300, this is 315, that's 330. I should be out at 1 point. There's 1, 1.4, and then back to 2. And I get that. Okay, that, again, that's a weird looking shape. Looks like a little bow tie or a airplane propeller or something. It's called a lemniscate. Again, I'm not sure. I don't remember if that's French. I'm not sure what it is, but it means ribbon. I do remember that. Okay, and so it's like this little ribbon that has been created. So again, not a big deal. Remember, if you see r squared, go ahead and solve it for r. That's going to create a square root, and then that's going to create some error messages. It's okay. Wherever you start getting those error messages, you're going to pick back up where you left off, so it's going to be fine. So take a look at your worksheet, take a look at these, plug in the values that you have, graph them to the best of your ability, and then let me know if you have questions.